Okay. Hi! Today you're gonna see me solder a bunch of PCBs and then get kicked in the balls by an assumption I made 3 years ago. Enjoy! Okay, so since the last time, our PCBs have arrived. Let's open them up. There we go. So that's the main PCB, looking good. Okay. Slider base. Right. Okay. So that's the one for the rotary connection from the rotating part of the sliding carriage to the cable chain. So this is just basically an adapter through with all the signals from the slip ring to the cable chain down here. This goes into the end part of the slider, so that's where you plug everything in. Yeah, it has the motor signals, and this big thing here is for the cable chain. So this is back and front side. This goes into the tilt mechanism. Yes, in the tilting part, you plug everything in from the slip ring, and on the back side there are 3 connections. One for the zoom motor, then another one to power the camera, which is a bigger connector with screw terminals, and then the trigger and focus mechanism. And these will be connected to these 3 connections under here, and that's where the PCB goes. Yeah, these 3 plugs here, and that's the new focus motor. PCBs I soldered today. This one for the big one for the base. That is for the beginning of the rail, where everything connects, like where you plug in everything in. That's for where all the camera stuff is connected. Power camera, focus, trigger, and that stuff. And this little adapter PCB. Okay, so the new PCBs are soldered and time to take the old thing apart. Old PCB, new PCB. So last time we removed the USB connection because it proved unreliable through the slip ring. Also we added these end stop pins here, and we pushed everything a bit together here to make it go easier through the cable channel there. Good, let's put it in. I have to make a brand new cable and connector for this big connector here, where everything goes to the ESP. Yeah, it used to be just 4 pins, but now I have 8 pins here. So this means new cable. So the way I do this, I'll show you here. That's good. So I have these 2-port connectors, or crimp connectors, and I need a 2x4. That's a 2x4. There you are. Yeah. And you put them, you crimp these little metal thingies onto a cable, clip it in here, and then you have connections like these. Yeah, connections like these. But it takes a bit of practice. The first few cables will fail and it's finicky, fine little work. Don't really like it, but it gives you very clean cables and connections, and that's the good part. They are mostly reliable if you do it right, and yeah, as I said, the first few will crimp and put in and then pull a bit on it, and then they break, and then you throw everything out the window. That's how I did it. Right, crimping. You need one of these. Can get them with the 2-port kit and everything for 10-20 bucks on Amazon. And this is probably the worst kind of crimping tool you can get, but it's cheap, and if you're just starting out, it's really enough. Okay, I need 4 of these. 8. Okay. Good cable. I'm using this big ribbon cable for that, and first you need the length, so I need about this much cable. And yeah, these are too many pins, so I just pull a few off. 8-pin cable. You want to pull them apart like so, and now you need to strip the isolation. Good. Now all the ends are without isolation. Okay, now let me move you in a bit closer. Okay, so now I prepare these tiny things. when you get them off their metal band, here and there, when you get them off their metal band, they're all like bent and or crooked. What I want to do is prepare them with these round pliers. And the way I do it, I grab them here, like so, and I kind of press a round shape into them. I so hope you can see this. Okay, now they are round at the bottom, and now they need these little arms need to come up again a bit. So with other pliers, these are like tiny needle nose pliers, like to get them straight again. So there, that's good. And now, once you have prepared them, you can just put the cable in here. And how do I show this? Well, maybe I put a graphic on screen. Basically, these little crimp connectors, they have two sets of, let's call them wings. So, okay. So these little metal things, they have two sets of kind of wings. The first, the bigger one, is there to catch the isolation, and the second set is there to catch the actual metal wire inside the cable. So when you put in your cable, the isolation has to end after the big wings. If you put isolation into the little wings, you won't have a proper connection. I'm gonna crimp on and hope I can show you. So once I put them in like this, I like to different pliers, pinch them together a bit. So now they hold on by themselves and they don't fall off, they don't agonize you, you don't have to burn down the whole thing, it just works. So put them in here like so, and then you crimp them. That didn't feel good, let's see if it has worked. Yeah, okay. Let's see. Here. Good, not great. The second pair of wings hasn't grabbed all the way. So what I like to do is do a bit of this here and shape them. See, to make them, yeah, now the contact is there. Okay, there you can hopefully see it's flat and there's no isolation inside the little wings. So now I will do the remaining set of 15. So that's 8 down, 8 more to go. Okay, that's both ends crimped. Took me about 8.5 minutes for one end. Got a little hiccup, maybe 7 minutes or so per end. Not bad. It has been a week since the last clip you saw. I got a little distracted in the meantime. And I've built a 5-axis robot arm. This is the U-stepper robot arm. You can find it online. Download STLs for the 3D printed part, and there's an excellent guide in there where you can build it yourself. Yeah, if you have printed everything, it takes about, I don't know, 2 hours maybe to put it together. Yeah. This thing moves and does everything. It's really quiet. I have added kind of, you can see it here, that's a 2-axis gimbal for my phone to clip in, and I can film short sequences with it, and I show you an example now. Okay, the good news is this works great. Well, except for the servo motors, they're a bit jittery. I will replace them with really small stepper motors, and hopefully it will improve. But this was more like a proof of concept for me to test out the wireless communication, because as you maybe remember, I wanted to move my controller to the ESP32 and use the wireless connection. But I've tried to get the wireless working for the last 2 days now, and it will not work. I tried WebSockets, I tried Telnet. Telnet was a bit more reliable than WebSockets, but it's not great. It's very, very slow response time. And WebSockets were completely unreliable. They worked like 5% of the time. So the way I have it working now is a USB connection to a Raspberry Pi. So basically what the target will be for the finished product or finished project. Bad news is I now have to add USB to my slider. If you remember the last episode, we just removed USB because it was unreliable through the slip rings, which therefore means I have to get rid of the slip rings, which is a huge pain because they are everywhere, and I have used them since the beginning, and now I have to get rid of them. See, there's a slip ring, and there is a slip ring. Yeah, it's just great. So I have to now redo almost all the PCBs and a lot of the CAD model as well, because I have to make sure that it doesn't spin indefinitely and rip the cables out. I have to limit the rotation to less than 360 degrees, and have to add some kind of end stop where I can push against. So a lot more remodel work when I thought I was almost finished. Yeah, but I'm pretty happy with the robot arm. That's great. I started it as maybe like a little weekend project, a little toy. But with the phone gimbal, I think this could actually be useful if I can get the rotation stable enough to be not jittery and keep the construction light enough, because this the end effector, when it's fully extended, can lift about, well, the specs say that it can lift about 250 grams, and that's not a lot to work with. But I thought, if this is not enough, I can maybe add stronger motors. These are 45 Newton centimeters, and I think I have 69 or 71 lying around somewhere. So I could beef this up a bit. Okay, I will show you now a little bit of the movement of the robot arm. Here you can see, this is my web interface. I've written for my pan tilt slider. I can control everything and set keyframes into animations and anything. Works pretty good so far, and I used it now to train a bit on the robot arm. So we have power, can move, and it's pretty quiet. You can't hear really anything from the stepper motors. I don't know if this even picks up on a microphone. Yeah, and this is now, the jogging speed is very slow. I did it like this so I can still control it, but if we do like an animation here, set a keyframe, move over here, and up a bit. Let's say we want to do this over 10 seconds. So, and if I hit play now, zip. It's so fast. Yeah, it's great. Yeah, okay. I think I will now continue working on the phone gimbal for the robot arm, because it's very jittery, and yeah, I've shown you the video. It's not a good result. But it's slow now because I'm jogging slow. I don't want to crash into anything. But you can also hear the motors. They're quite loud. And it's also not so, it's not a stable construction for now. I have to improve this a bit, because if I move really fast, it starts to shake. And yeah, I can't have that. Okay.